Hi, good morning. This is Trina here to discuss about the substitution reaction today. This is the part of organic reactions. And in my personal information, I have given my email ID and the contact number. So if you have any doubt, you can communicate with me. And the most important part is the course page. Here I have uploaded all the study materials and the probable questions, the semester questions, and also the solved problems. So first of all, you have to join with the given code, then you can access all the study materials. The subject name is chemistry and the subject code CH101 for odd semester, CH201 for even semester. And this course is for BTech UG students and the streams are CSE IT Civil Mechanical for even semester and Electrical EC BME for odd semester. The credits 3, contact hours 35. So weekly I will take 3 lectures. And the prerequisite knowledge required to understand this concept of chemistry, that is 12 standard. And the course objective, here you will learn the different concepts of the chemistry. And the lecture plan, the lesson plan is given here that tells that each lecture will cover which topics. So today I am telling about the organic reactions, that is the module 3. So you can see here that is already highlighted. So organic reactions, this part. And already I have covered in my first lecture, that is the electronic effect, and today I will tell about the introduction to reactions involving substitution. So students will be able to understand the basics of organic reaction mechanism from these lectures. And here the textbook also given of organic chemistry. So you can also avail it from the library. So in the starting, I like to check that how much you have learned the previous lecture of the organic reaction. That was on electronic effect, the inductive effect, the resonance effect, electromagnetic effect, and the hyperconjugation. So first you solve few questions which already came in different semester. Number 1, why para-nitrophenol is more acidic than phenol? And then why para-nitrophenol has higher boiling point than ortho-nitrophenol, although both have same molecular weight? So one by one we will solve. So first question is why para-nitrophenol is more acidic than phenol? So the electronic effect, what you have learned like resonance or inductive effect. So this tells about the stability of the element or the stability of the compound or the basic part or acidic part, etc. So also you can understand from the stability, also you can understand that which one is more acidic or which one is more basic. So here our question is why para-nitrophenol is more acidic than phenol. So what is the difference in their structure? You have to think about that. What is the difference? So first, look at the structure. So para-nitrophenol, that contain that with the phenol at the para position there will be NO2, the nitrate group. So here you can see the resonating structure. So this is the para-nitrophenol and this is the only phenol. Okay, phenol means with the benzene ring there is OH group. So that is the phenol, and para-nitrophenol additionally at the para position there will be NO2 group. Now how we can understand? So you know that NO2 is the electron withdrawing group. So it has the minus I and minus R effect, the nitro group. So because of these two effects, NO2 group is electron withdrawing in nature. So the electron density in the OH bond of para-nitrophenol decreases relative to the OH bond in phenol. So in the phenol there is no nitro group, so there is nothing to withdraw the electron from the benzene ring or from the OH minus. But in the para-nitrophenol there is the nitro group, which is the electron withdrawing group due to the minus R effect and minus I and minus R effect. So what happens? Basically, we have to consider this ion, because to become acidic we know which can give easily the OH plus ion, that is base, that is acid. You know very well that which can give the hydrogen, that is acid. So after giving this hydrogen H plus ion, if the phenoxide ion is stable, then we can say that that is the strong acid. So here we are taking the phenoxide ion we are getting from the phenol when it gives the release the H plus ion, and another is para-nitrophenoxide ion. So which is more stable we have to consider. So para-nitrophenoxide is more stable than the phenoxide ion. That is why para-nitrophenoxide can give easily the H plus ion. And that is why the nitrophenol is more acidic. So let's see the resonating structure. Okay, so first one is for phenoxide and second one is for para-nitrophenoxide. So you can understand that as the nitro group, that NO2, is withdrawing the electron, so after giving the H plus ion, it becomes more stable rather the phenoxide ion. That is why this one means the para-nitrophenol is more acidic than the phenol. Okay, so you are clear. So to explain this question, that why the para-nitrophenol is more acidic than phenol, you have to give the structure of phenoxide ion, that is the structure. So you can see that how the negative ion in the benzene structure, and here you can see that as it is withdrawing the electron, so how it is stabilized, the negatively charged. As it is more stable, negative charge is more stable as NO2 group withdrawing the electron from OH bond also. That is why it becomes more stable. The negative charge become more stable in the nitrophenoxide group. So you have to draw this figure and then you have to explain. And the next question was why the para-nitrophenol has more boiling point. So in the para-nitrophenol, molecular association takes place due to extensive hydrogen bonding. Okay, in para-nitrophenol, there will be the molecular association of extensive hydrogen bonding between the molecules and intermolecular hydrogen bonding. Therefore, it has higher melting and boiling point. But in orthonitrophenol, since the OH group and the NO2 group are in close proximity to each other, intermolecular hydrogen bonding takes place. So the molecular weight is not increased such a way. So the para-nitrophenol has the higher boiling and melting point than orthonitrophenol. Okay, so you are clear about these two questions. If you have doubt, you will contact with me. Second question, it also came in 2018-19 in the semester exam. So which one is more basic between aniline and methylamine and why? So it is the question about the basicity. Initially you learned that which one is more acidic and now which one is more basic. So which one is more basic? Which can give the electron to proton, that is the more basic. So first of all, we have to draw the structure. So first you can see the methylamine. So which one is more basic? What you think? Methylamine is more basic compared with the aniline. And why so? You have to explain with the diagram. So here you can see the structure of aniline, different structure of aniline, and you can see this lone pair of electron, how it is delocalized in the resonating structure. So here are different structure given. So in this way, the negative charge is moving throughout the structure, delocalized. So it is not much available for the protonation. But for what happens for the methylamine? Now let's see what happens in the methylamine. So this is the structure of methylamine. You can see here the lone pair of nitrogen and the methyl group is attached here. So due to this plus I effect, that is the inductive effect, the CH3 is donating electron to the nitrogen. So nitrogen becomes rich in electron. So it can easily donate electron and it can easily give to the proton, electron to the proton. So what we can conclude, as the electron available in the methylamine, availability of electron in the methylamine is higher, so it can donate electron pair to the proton. So aniline act as less basic. So here you can see that nitrogen does not give the electron pair to proton in the aniline. So aniline act as a less basic as its electron remain delocalized throughout the ring structure. Okay, so you have understood that how basicity and how acidity can be explained by the electronic effect. Next, why formic acid is a stronger base than acetic acid? So acidity, when you justify the acidity, like the first question, so again you have to take the conjugate base. So for formic acid, the conjugate base that is the formate ion. That is formate ion. That is the conjugate base of formic acid. And for acetate ion is the conjugate for acetic acid. Now, which one is more stable? Which one is more stable you have to consider. Which one is more stable? That is more acidic. Because acid can give easily H plus ion. So after giving the H plus ion, that is the conjugate base, if it is more stable, then we can say that is more acidic. Okay, so here you can see the structure. So it is the formic acid and this one is the formate ion. Formic acid and formate ion. And now it is the acetic acid and it is the acetate ion. So if you consider that in this case there is no methyl group, here is no methyl group, so only hydrogen, but in the acetate ion there is the methyl group. So what will happen? Due to the inductive effect, due to this inductive effect, plus I effect, this will give electron to the carbon, and as a result the electron density will be increased here. So it becomes less stable. So what is your answer? Answer is the formic acid is stronger acid than acetic acid. So you can justify acidity and basicity factor by the electronic effect. So now I am going to start the organic reactions part. So organic reactions are chemical reactions involving organic compounds. There are mainly 5 types of organic reactions: the substitution reaction, elimination reaction, addition reaction, oxidation reduction reaction, radical reaction. So today you will learn about the substitution reaction. So from the word substitution, you can understand that any of the group will be substituted by any other group. That is the main part of the substitution reaction. So substitution reaction is a chemical reaction during which one functional group in a chemical compound is replaced by another functional group. So substitution reactions are of prime importance in organic chemistry. So to understand substitution reaction, you have to know what is nucleophile. So nucleophile is a chemical species that donates an electron pair to form a chemical bond in relation to a reaction. All molecules or ions with a free pair of electrons or at least one pi bond can act as nucleophiles because nucleophiles donate electrons. They are by definition Lewis bases. Okay, so what are the example of nucleophiles? It is like chlorine minus, Cl minus, ammonia, NH3, which can donate the lone pair of electron. Okay, so these are called nucleophiles. Now, the substitution reaction is of 2 types. The nucleophilic substitution unimolecular reaction, that is called SN1. Another is called nucleophilic substitution bimolecular SN2 reaction. So we have to learn the mechanism of SN1 and SN2 reaction. So SN1 corresponds to unimolecular nucleophilic substitution. The rate depends on concentration of only one reactant, the substrate, and not the nucleophile. So what happens? Factors affecting SN1 reaction: the nature of the substrate, the rate of leaving group departure, the nature of the solvent. So in the mechanism part, the first step there, it occurs by two steps. First, you can see it is the slower step, and the second step, that is the faster. The first step of the reaction involves the formation of carbocation. This is slow process due to which activation energy for bond breaking. Carbocation can stabilized by the substituents through two important effects: hyperconjugation if the carbon is highly substituted, or by resonance. And what happens in the second step? The second step proceed first, as it involves combination of two ionic substrate and the incoming nucleophile. So here you observe that first we are taking this one. So what I told that first which will be produced, first the carbocation will be produced here. So first bromine is left from here. Now the carbocation is produced. Then it is attacked by OH minus, that is a nucleophile. After that we are getting our product. So observe one part, that in this product, you notice at the product and notice the reagents. So the structure looks like the umbrella. Okay, then umbrella open like this side, and in the product also the umbrella remains in the same side. That is the observation. So you have learned the mechanism of SN1 reaction. So in the SN1 reaction, first carbocation is formed, then it is attacked by nucleophiles. So next, SN2 reaction. So in the SN2 reaction, what happens? First, it is attacked by nucleophiles. Okay, look here in this picture. So first, it is attacked by the OH minus. First, it is attacked by nucleophiles. After that, it is a transition state. Then the chlorine is removed. Chlorine is removed and OH is attached. So we can say that OH replaced the chlorine. Chlorine is replaced by OH. So initially there was, in the reagent there was chlorine, and final product we are getting the Cl is replaced, Cl minus is replaced, and OH minus is attached here. Now look at the structure. So the umbrella shaped, the umbrella facing is this way, but in the product the umbrella facing is that way. Okay, so you can look the difference, and on this you may get the questions. So I will discuss the questions, then you can be more clear. If I summarize today's lecture, so what you have learned today? You have learned to solve different questions of the semester from the electromeric effect, different analytical question. That means which is more basic or which compound is more acidic, you can explain with the structure. And number two, you have learned the substitution reaction. and two types of substitution. One is SN1 and SN2, that is very important. And also you have learned the mechanism of SN1 and SN2, and also learned the definition of nucleophiles. Okay, now let's check that how much you have learned. There are few questions. First MCQ question, that the which reagent, okay, which reagent is a good nucleophile? So can you guess the answer? Which reagent is a good nucleophile? So the example already I have given during my lecture. So it will be NH3, the ammonia. It is the good nucleophile, as the nitrogen can donate the lone pair of electron. Okay, next question. Which of the following is not true about nucleophile? So first option given, donate an electron pair to an electrophile to form a chemical bond. That is correct. All molecules or ions with a free pair of electrons or at least one pi bond can act as nucleophile. That is also correct. Okay, next is nucleophile are Lewis acid by definition. So remember, it is Lewis acid or Lewis base. And next is a nucleophile becomes attracted to a full or partial positive charge. So it is also correct. So which one is not true? Which one is incorrect? So answer will be nucleophile are Lewis acids by definition. Okay, next come to the short answer type questions. And this is very first question tells, write the difference between SN1 and SN2 reactions. This question is very common question. SN1 and SN2 difference. So first of all, you can give the structure, the mechanism. Okay, you can draw this structure. So here you can give SN1, this is for SN2. Takes place, SN1 takes place in third degree alkyl halides, and SN2 takes place in 1 degree alkyl halide. Next, in SN1, the reaction you have seen the two steps. One is the first one is a slower process, second one is the faster process. And the SN2, that is only one step. Third one, first step is slow and rate determining. And in the SN2, only one step. Number 4, rate alpha to concentration of the alkyl halide. And here also rate is alpha to concentration of alkyl halide and alkali. Okay, that is why it is SN2 by molecular, depends on the concentration of two reagents. It is the unimolecular, the similar thing they are telling, that is the bimolecular. Non-concerted, concerted. Independent of concentration of alkali, the similar thing it is telling again. And dependent of concentration of both. Carbocation intermediate is formed, take place via only transition state. Racemic mixture is formed. Here the Walden inversion takes place. Favorable in protic solvents like say H2O, HCOH. Aprotic solvents DMSO, DMF, etc. And order of reactivity, third degree greater than 2 degree greater than first degree. Here the order of reactivity, first degree, then greater than 2 degree, second degree, then the third degree. And rearrangement may take place. No rearrangement takes place. So you have learned the lots of differences between SN1 and SN2. So next question is, SN2 reaction occurs with inversion of configuration, whereas SN1 reaction occurs retention of configuration. Explain with suitable example. So this question also came in 1819 even same. So I have already shown you, and you maybe you cannot understand the language here, the what question wants. So basically I will show the structure, then you will be more clear. So SN1 reaction occurs with the inversion of the configuration, SN2, and SN1 reaction occurs retention of the configuration. So what it is telling? Configuration, that is the structure. So for SN1 remains the similar structure with the reagents, with the similar structure of the product with the reagents. But SN2 is the inversion of the configuration. So a nucleophile electron-rich species having affinity towards electron-efficient center can attack the stereo center in two ways, like it can attack from front side or from the back side. In front side attack, the nucleophile attack the stereo center from the same side of the leaving group. The result is retention of configuration that takes place in the SN1. Okay, so look at the structure. Okay, it is the SN1. So the nucleophile attack occurs at the same site. So what you can see here, bromine is this site, bromine, and the nucleophile OH attack this carbocation at the same site, OH. Okay, so what we get? We get the retention of the configuration. So I shown you before the umbrella shaped. You have observed. So the configuration, it is like, look like the umbrella, it remains in same direction. So configuration remains same. So it is called the retention of the configuration. So this is our umbrella. But for SN2 reaction, what happens? In the backside attack, the nucleophile attacks the stereo center from the opposite side of the leaving group. This results in formation of the product having inversion of configuration. So let's have a look again. So which one is the stereo center? That is our stereo center. Before also the middle, the carbon. Now the OH attack from the back side. Okay, here you can see the OH, just 1 second. Okay, so OH attack from the back side. You can see here, but chlorine is leaving from another side, from the front side. So as a result, you can see the umbrella shape, the configuration, it occurs the inversion. So it is in this direction, our umbrella, but this is the reverse direction, opposite direction. Okay, so you are clear about the answer. It is very easy answer. it was difficult for you to understand the questions. Okay, so this is the answer. So I hope that you have enjoyed my class. You have understood very well the today's topic. If you have any doubt, you can contact with me. So I am ending the session today. Thank you, everyone.